All right, boys and girls, this is assignment 3L worksheet. This is a review. This is much like the previous assignment. However, we do have some additional problems in which they ask us to write equations of lines and things like that. So again, we are going to do our best to get these derivatives, and then most of them require some sort of cleanup process, but we'll cross that bridge when we kind of get there. So the idea of getting a good derivative out of these things is first understanding what is inside of what as far as the chain rule is concerned. So like problem number 1 here, you have to feel comfortable with writing square roots as like to 1/2 and things like that. So I can recognize the outside and the inside and things. All right, so the derivative of this, the derivative of the outside is that power of 1/2. So that's 1/2, leave the inside alone, minus 1, and then times, and then I take the derivative of the inside, so 2 goes away, 3s squared is negative 6s. Cleaning that up, this is in essence negative 3s, so the 1/2 in this negative 6s, and then I have a 2 minus a 3s squared to the negative 1/2. This is pretty decent, but you will never see this answer on actual assignment. So what this would be is the negative 1/2 would be a denominator of a square root. So how this would look is this would be 2 minus 3s squared as the denominator of a square root, and then that's a negative 3s. So that's what it would look like. So I just move things, numerators go to numerators, denominators go to denominators. A lot of times it's just simplifying negative powers. Rarely will you actually see a negative power. All right, number 2, we have this g of x. Again, I'll rewrite it so it's a little bit more understandable. So that's the third root, so it'll be to the 1/3. So I can go ahead and take the derivative of this. So I address the 1/3 power. So that's the outside of the onion. So I drop that down, don't touch the inside, and then I multiply by these the derivative of the inside. So that's 8x. Simplifying this, this will be 8/3 x. 4x squared minus 1 to the negative 2/3. Okay, again, I'm okay with that guy right there. But again, what it's going to look like. Typically, they don't simplify an exponent that has like to the 2/3 or to the 4/3 or something like that. Typically, the only time that you'll see a root coming out of that, if it's like a perfect to the 1/2 or to the 1/3 or something like that. But any time that you have like a 2/3 or something like that, it'll stay as an exponent. However, as I said before, they will take care of the negative. So here we have a 3 on the bottom, an 8 on the top, an x on the top, and a 4 x squared minus 1 to the 2/3 on bottom. As I said, the 8 is on top and the x is on top. That's what it's really going to look like. All right, here we have the f of x, which is going to be a 4 secant x to the 1/2. So the 4 secant is on the outside. So this is going to be, so the derivative of that, secant goes to secant tangent. So this is going to be 4. Here goes the secant. So this will be secant tangent, secant tangent, that's the derivative of that. And then the inside would be the x to the 1/2. So here comes the chain rule of x to the negative 1/2. All right, so this would be what? 2x to the negative 1/2, secant x to the 1/2, tangent x to the 1/2. And again, so I'm okay with that. I'm okay with that right there. Fine, fine, fine. However, how is it really going to look? This is going to be a 2 on top with a secant on top with a square root x, a tangent on top with a square root x, and a square root x on the bottom. That's what it's really going to look like. So again, when you clean this up, or if they ask you to clean it up, again, the major part about it is take care of negative exponents. Negative exponents always go, to the bottom or to the other side, whatever the case may be. And then if you have a simple fraction, like a 1/2, those are going to be roots. However, if you have like a complicated fraction, like a 2/3, then oftentimes it will stay as a 2/3. All right, number 4. So all of this is on the inside, so sine x to the 1/2. So here comes the derivative, so the g prime is 1/2, 3 sine, the negative 1/2. The derivative on the inside is going to be 3 cosine x. And then the derivative on the inside of that is 1, so it's not a big deal. All right, so that is that. So putting the numbers up front, this is going to be a 3/2. 3/2, and then I have a 3 sine x, the negative 1/2, and a cosine x. Okay, I can't multiply out this 3 right here because it's a it's going to be part inside of a square root on the denominator, so it's not a 3 as it looks. Okay, so I can't just simplify that portion of it. So again, I'm pretty cool with this answer right here. How is it really going to look? And so I see this 3 is a top, the 2 is a bottom. I have a cosine x on top, and then I have a square root of 3 sine x on bottom. So as I said, that 3 that is with that sign isn't an actual 3. It's not simplifying or combining forces or anything anywhere. It's just kind of is what it is. All right, this is going to be an effort to understand common denominators and doing chain rule as well as product rule. All right, so what do I have with h of t right now? So I have that numerator, which is t minus 1 to the 1/2. And I also have that denominator, which is t plus 1, but because it's a denominator, it'll be to the negative 1/2. So I have to do the product rule while simultaneously doing the chain rule. Not really a whole lot of chain rule, but whatever. Okay, h prime. So I take the derivative of the first, like u prime, for instance. And that's 1/2 t minus 1 to the negative 1/2, and then you would multiply by 1 if I were straight up doing the chain rule, but a multiplication of 1 is just kind of a waste of time. All right, so that's u prime v. So the second part is just left alone, plus v prime, so the derivative of that second piece. So that's negative 1/2 t plus 1 to the negative 3/2. And again, the chain rule would imply times 1 because of the inside t, but again, don't really work. So that's v prime u. t minus 1 to the 1/2. That's u prime v plus d prime u. That's pretty good. That's pretty good. Again, it doesn't look good, but it's pretty good. This, as I said, this is going to be an effort of the cleanup process. So I'm pretty decent with that answer, but let's get into it a little bit. So right now, just put things on proper sides. I have a 2, t minus 1, t plus 1 on bottom. This is going to be a minus because of the negative 1/2 part of that. This is going to be a 2, t plus 1. I'm going to write this as the square root of t plus 1 to the 3rd power. Okay, I'm going to just kind of write that just temporarily. And then I have a t minus 1 on top. All right, so I put things in the proper places. Okay, and now it's just an effort of getting a common denominator. So I multiply the tops and the bottoms by the same thing. So 2 and 2, that's good to go. They both have 2's. This side needs a t minus, the right-hand side needs a t minus 1. So I'm technically putting a t minus 1 in with the denominator. However, I'm just doing quick and dirty math. I can keep track of that in my brain. So I need to multiply by a t minus 1. So what you'll notice is these will multiply each other. Thus, a t minus 1 will become a quantity of t minus 1. That's what will happen. The t plus 1. The left-hand side has 1 of them. The right-hand side has 3 of them. That means I need to put 2 more over here. Let me write it a little bit differently. So it has 1, but it needs 2 more. That means I need to put 2 more of these on the left-hand side. So I'll have 3 square roots on the left-hand side. But notice what that is. A square of a square root is just the inside itself. So this side just needs a t plus 1. And that's technically 2 of the square roots. Okay, so what do I have? I have a t plus 1 minus, okay, so again, this has to distribute inside the newly created parentheses here. And so that's going to be minus t plus 1 all over 2, square root of t minus 1, and then I'll go back to the parentheses. This is t plus 1 to the 3 over 2. I see that the t's drop and the 1's join, so this is 2 over 2 t minus 1 t plus 1 to the 3 over 2. Ugh, very googly moogly, and then these 2's simplify. So this is 1 over t minus 1, t plus 1, and that is your simplified version. Okay, next we're asked to write some equations of tangent lines. So what a derivative is the slope of a tangent. So they'll maintain the same point. All right, they'll maintain the same point, but you have to get the slope at that point to make the clock tick. All right, so right now our f of x is x squared plus 9 square rooted, so that means to the 1/2. So working my way towards the slope of the tangent, I take the derivative. So the derivative is going to be 1/2 x squared plus 9, negative 1/2 times the chain rule, which is 2x. Cleaning that up, that's an x squared plus 9 in the denominator of x. So I noticed that that 2 and that 2 drop. And so that's kind of the cleaned up version. Okay, so that's what the derivative is. Okay, that's all fine and dandy, but I need to know where is the derivative, what is the slope at specifically when x is equal to 4. So when x is equal to 4, I see that I have 4 squared plus 9 all underneath 4, so this is going to be 4/5. So the slope of my tangent is 4/5, and it goes through the point of 4, 5. It's just a coincidence, but that's what I have. So this is the slope of my tangent line. So again, the derivative is the slope. So what I have right now is I have a line that has a slope of 4/5 that goes through the point of 4, 5. So I go y minus y1 is equal to m x minus x1. And then I need to add the 5, but I put it in versions of fifths, so that'd be 25/5. That's me adding the 5 across. So this is, what, 4/5 x and a positive 9/5. Find the equation of the normal line at the origin. So the origin is technically at the point 0, 0. The normal line, what the normal line is a perpendicular. So that implies that the slope is going to be an opposite reciprocal. You'll see what I mean when I get there. So first and foremost, let's take a look at what we have. We have an x times a 16 plus x squared in a square root. So we need to find the slope of the tangent. So the f prime. So I take, this is going to be the product rule. So u prime v plus v prime u. So u prime is the x, that is that front x, which goes to 1. So u prime, 1, v. Plus v prime, so that's the second part, that's the 1/2. There's a chain rule that goes along with this. Times x. And again, what that is this is u prime v plus v prime u. So the derivative of that u in the original goes to 1, so that's why you don't see it. Okay, let's clean this up for ourselves. Sorry, this should be to the negative 1/2. So I totally missed that. So this is going to be a square root of 16 plus x squared plus 2 cancels 2. And so this is going to be what, x squared over top of 16 plus x squared. So getting a common denominator, this is going to require 16x squared in a square root. The right-hand side means nothing. So what this cleaned up version is, back to blue here, is going to be 16 plus x squared. So that's the square root times the square root right there. This is 16 plus x squared. Plus x squared, that's the second fraction, that's all over 16 plus x squared u. Let's go one more. So that's 2x squared plus 16 over 16 plus x squared square root. Okay. A lot of cleanup for something that we're not even done with yet. So let me kind of minimize some of this and give myself some workspace here. Okay, so that's the derivative. But now I need to know what is the slope of my line. So what is the slope of the tangent? And so what that is going to be is what is the derivative at 0. And so that makes our math pretty easy. That leaves us with 16 on top, square root of 16 on bottom, so that's going to be 4. Okay, so the slope of the tangent line is 4. However, I don't want the slope of the tangent line, I want the slope of the normal line. And again, one more time, what that is this. If I have a tangent line, something like that, a normal line is perpendicular to the tangent line. So that means the slope of my perpendicular line will be an opposite reciprocal. So the slope that I'm dealing with in this problem, let me switch to purple, is going to be an opposite reciprocal of 4, so that's going to be negative 1/4. Opposite, making it negative, and then 4 over 1 becomes 1 over 4. And that still goes to the point 0, 0. So that will be the slope of my, that'll help me find the equation of my normal line. So y minus y1 is equal to m x minus x1. So a bunch of stuff drops, one thing doesn't, and that's the negative 1/4 x. I find the equation of the tangent line at the curve, blah, 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 blah. Okay. So the equation of the tangent line, so I need to know the derivative. I've done enough of these, you understand the chain rule without me writing it every single time. It'd be a plus, but cosine goes to negative sine. Okay, that's your chain rule. That's your chain rule. That's your derivative. I'll do one cleanup. Okay, so that's your derivative. Now I need to find the slope of my tangent. And so the slope of my tangent, my x is 1/4 pi. So I need to probably know what a bunch of these sines and cosines are at 1/4 pi. So taking a look at that, the reason that they use that one is because they're both the same. They're both square root 2's over 2's positives. All right, so this is going to be square root of 2 over 2 minus square root of 2 over 2 over 2 square root 2 over 2 plus square root 2 over 2. So this is going to be 0, obviously, on the numerator, and the denominator is going to be 2. And then think of this kind of like as like a 1/2 plus a 1/2 kind of thing. A half plus a half is a whole. So this is, the whole is going to be a square root 2. So this is going to be a square root of 2. And I'll talk about that here in just a sec. But ultimately, this is equal to 0. So the slope of my tangent is equal to 0. Okay, we're not done with the question, but that was a major chunk. Okay, now we need to know what is the point. Okay, the point, like what is the y coordinate? So what is the actual find the slope, find the equation of the tangent line to the curve, blah, 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 at the point where that is at. Okay. So when I'm in the effort of creating an equation of a line, I need a slope and I need a point. But the problem is I currently don't have a y coordinate of that point. I currently don't have a y coordinate. So I need to do a little bit of work. Where do I go to find a regular y? I go to the regular equation, the regular original equation, and I'm investigating and I'm making my x 1/4 pi. So I go back to the original, the original function here. And what I see is this is going to be the square root of the sine of that is the square root 2 over 2 plus the square root 2 over 2. As I said, I was going to get back to this one. This is the regular y. And so this is going to be the square root of 2. Okay, the square root of the square root of 2. It might help if you think about this as parentheses. So 2. The square root of 2 is 1/2. So the square root of the square root. So here you have a power to a power. Power multiply now might kind of help you understand what the heck is going on here. And that would be a 2 to the 1/4, or AKA the 4th root of 2. The square root of a square root is a 4th root. So that gave me my y coordinate, which is the square root of 2. Now, what is the equation of my tangent line at that curve? Y minus y1 is equal to mx minus x1. So 0 eliminates this whole thing, and then I add the 4th root of 2 across. So the equation of my tangent line is y is equal to the 4th root of 2.